Dear students, this is our 7 lectures of the forecasting. Please pay attention, and sorry for the interruption of the last lecture because I used the program that make interruption in the last lecture. So pay attention. We explain simple moving average, and we say that MA, or the moving average, which is depending on K observation. K is the length of the moving average, or degree, order of the moving average. YT plus J is the series values that contribute to the average, which enter to the average, which we add them to in the denominator, and YT is the center of the average. The first example of moving average method. The following data represent number of students in a department. There is 2 given data. The first one is the year. The second one is number of students. And we want to calculate the 3 years and 5 years intervals moving average. Here we make a table that contains on these 4 columns. The first and the second column is given. The third column is the moving average at order 3. We sum these 3 moving averages, these three number of students in the year, in the first year, in the second year, and in the third year. We sum 240 plus 280 plus 300, and we divide them over 3, and we put the moving average at the second or in the front of the second observation here. Okay, then we will add the second observation, the third and the fourth. We drop the first one and we add newest one. So we will add 280 plus 300 plus 260 and divide them over 3, and we will put the result at or in front of the 2002. Here we will put this value. It is the moving average of order 3 of 280 plus 300 plus 260 over 3, and so on to reach to the final of this table. We will notice that at the first year and at the end years there is no moving averages, but in moving average 5 we will add the first 5 observations, which is 240, 280, 300, 260. Finally, we will add 340, and we will divide them over 5. And we will put the result in front of the middle observation. The middle observation is at the year of 2002. which is in front of 300 students. 2 observations up and 2 observations down. We will put the result here in front of this year. And then when we want to add to obtain the MA5 at this year, we will add 280 plus 300 plus 260 plus 340 plus finally 360, and we will put it at the middle observation, which is here in the front of 2003, and so on to reach to the final. We notice that the first observations and the first and second observation and the last and the last of observations, it is blanked. Note that the term moving average is used to describe this procedure because each average is computed by dropping the oldest observation and including the next observation. So we drop the oldest and add newest, so on to reach to the final of the table. The averaging moves through the time series until the trend cycle is computed at each observation, for which all elements of the average are available. The number of data points in each average remains constant and is centered on the observation for which the trend cycle estimate is computed. The moving average series is k minus 1 value, less than the original series. The moving average series are less fluctuated than the original series as shown in the graph. As k increases, the series is less fluctuated, but we lose more observation, unfortunately. The simple moving average gives the same weight for all observations. Sometimes we need to overweight some observations, such as the most recent one, the last observations in the series. This is the main idea of the following averages. We will discuss the weighted moving average now. The weighted moving average in general, a weighted k point moving average can be written as y hat equal the moving average, which is equal to the summation of the multiplication of ai multiplied by yt plus plus I. For the weighted moving average to work properly, it is important that the total of weight is 1. The total of weight is equal to 1. The advantage of weighted moving average is that the resulting smooth trend cycle is much smoother. This is our objective. Example: given weekly demand and weights, what is the forecast for the first period or week 4? This table is given, and this weights is given also. We will multiply all the week 1 demand with its weight, which is 0.2, and so on. We should notice that all the summation of all weights is equal to 1. Given the second example is, given the weekly demand information and weights, what is the weighted moving average forecast of the 5th period or week? When we sum all all of these weights